Right, this little video is about two integrals involving trigonometric functions. The two integrals look fairly similar at first sight, but actually turn out to be quite different. The first of these is the integral between 0 and pi upon 2 cos squared theta sine theta d theta divided by 1 plus a cos squared theta. So if we just make the simple substitution u equals cos theta, so that du equals minus sine theta d theta, the integral transforms to minus the integral between 0 and 1 of u squared du over 1 plus a squared u squared. I've just got rid of the minus sign by inverting the limits to get the integral between 0 and 1 u squared du over 1 plus a squared u squared. Now there's just a little bit of a fiddle in the next bit, which I don't think is too difficult to follow. So what I've done is written down as 1 over a squared, integral between 1 and 0, a squared u squared plus 1 minus 1 over a squared u squared plus 1. And that comes down to 1 over a squared, just 1 minus 1 over 1 plus a squared u squared du. And the integration now is fairly standard. That's 1 over a squared u minus tan inverse au over a. And inserting the limits, we get 1 over a squared into 1 plus tan inverse a over a. Well, that does the first part. The second part, as I've said, looks fairly similar, except the denominator has a square root sign. I must admit I had to make 2 or 3 attempts at this one before I found a fairly tidy solution. So I've used the substitution here of sinh x equals a cos theta. And so cos x dx is minus a sine theta d theta. And forgetting the limits pro tem, the integral transforms to minus 1 over a cubed integral sinh squared x cos x dx over the square root of 1 plus sinh squared x. As 1 plus sinh squared x is cos squared x, the bottom becomes cos x, which cancels with the cos x at the top, and we're left with 1 minus 1 over a cubed integral sinh squared x dx. Now this I've done by parts, and when I do that, I get this next line here, minus 1 over 2a cubed sinh x cos x minus x, and then I've restored the limits to sinh x equals 0, and the bottom limit sinh x equals a. I've now got rid of the minus sign by switching over the limits. And when we put in the limits, we get this bit here, 1 over 2a cubed into a square root 1 plus a squared minus sinh to the minus 1a, which equals 1 over 2a cubed a into square root 1 plus a squared minus log to base e a plus square root 1 plus a squared. This last bit here, that should read sinh inverse a. It was a bit untidy, for which 1,000 apologies. Now, for those of you who are slightly unfamiliar with one or two of the steps I've used here, I've got some explanation at the bottom. The first one was integrating sinh squared x, which is a product, of course, of sinh x times sinh x. And then by parts, I will equal sinh x, the first times the integral of the second, so that's sinh x times cos x, minus the integral of the diffco of the first, which is cos x, times the integral of the second, which is also cos x. And so in the next line we have sinh x cos x minus the integral of 1 plus sinh squared x, because cos squared x is 1 plus sinh squared x. And so that's quite then easily becomes sin x cos x. Integrating the 1 just becomes minus x, and integrating the second part is just our original integral I. So that I equals sin x cos x minus x over 2. Right. So that does the that little integration by parts bit. The second bit is transforming sinh inverse a into its logarithm form. So if we let y equals sinh inverse a, then a is sinh y, which equals by definition e to the y minus e to the minus y over 2. So that 2a equals e to the y minus e to the minus y. And now I've multiplied up by e to the y and transferred everything to one side. So we get a quadratic equation. 0 equals e to the 2y minus 2a e to the y minus 1, which I've then proceeded to solve just using the quadratic equation formula. And that gives me e to the y equals 2a plus square root 4a squared plus 4 all divided by 2, which simplifies to a plus or minus square root a squared plus 1. So that now, taking logs of both sides, we have y equals log to base e, a plus square root a squared plus 1. Now I've taken the positive alternative, otherwise the argument of the logarithm would be a negative quantity, in other words, a complex number. So I hope that is reasonably clear. Thank you very much for listening.